Hey guys, so this channel is all about DevOps. That's why it's called DevOps Doctrine. Now, the first video should be what is DevOps? And that's what this whole video is going to be about. I'm going to explain DevOps at a high level. Now, in order to explain what DevOps is, let's start with another title that's a little bit more familiar, software engineers. What do software engineers do? They are the ones that develop the application, the software, right? But here's the question. So how does that software get into the hands of real customers? Let's use an analogy here. Think of toy production. Okay, you're developing toys. The software engineer is going to be the toy maker, the people that are actually making the toys. The DevOps engineer is going to take that toy, hop into their truck, the UPS driver, and they're going to deliver that after having packaged it and all that, tested it, they're going to take that toy and deliver it into the hands of real customers, right? With software, it's the same premise. Developers are the ones that are developing the software packages, software applications, and DevOps, instead of hopping into their truck, they're using a pipeline to send that software into the hands of real customers. So the premise is the same. Now, what is the impact of DevOps? The impact is, well, it makes your life better because as a software engineer, you don't have to worry about how it gets into the hands of real users. You leverage DevOps as a philosophy to send your software in a secure, reliable, repeatable way to the hands of real people. And it's all about accelerating delivery. You want to be able to do this faster and faster and faster. That's the hope, that's the premise, right? So that if you have new features, new things you want to send into the hands of real customers, it gets there faster and faster. So that is what DevOps is at a high level using that analogy of toy production. The agenda is basically going to be what is DevOps? I'm going to go a little bit deeper into that. The three pillars of DevOps, pipelines, IAC, KPIs, and if you guys have any questions, just leave a comment to this video and I will answer that question. Or if you have any comments in general, not a question, comments, leave it in the comments section. Okay, so in order to go into what DevOps is in further detail, I should start with a question. So think about it. You're developing software, okay? So you have a commit, that's your code commit, and you want to send that code commit to production. Let's call that the software development lifecycle, just in terms of this video. So what are some pain points that you're dealing with that can be solved with the DevOps philosophy? I want you to keep that question in your head as I progress through the rest of the slides. We will come back to this at the end, and as the pain points come up in your mind, jot them down, okay? So what is DevOps? DevOps is not a team, okay? I don't want to think of DevOps as a team, and I don't want you to think of DevOps as a team. That's the DevOps team. Yes, there are DevOps teams. However, what is DevOps? DevOps is a philosophy in principle. It's a mindset in culture, and it's a process, okay? And the end result is faster delivery, more stable deployments, elimination of silos where development and operations are not seen as two separate entities, but as one cohesive unit. And we typically like to use this like infinity symbol because it's a forever process that is forever developing to the point where you get more cohesion, faster releases, faster releases. But that process is essentially you code, you build that code, you test it, you release it, deploy it, operate on it, monitor it. If there are any issues, you plan and you code, build, test, release, deploy, operate, monitor, and so on. It's this continuous process that keeps going. If developers adopt a DevOps mindset, they tend to be happier. And if they don't, they tend to be a little bit sadder. That's my practice, that's my experience that I've seen. If you develop a DevOps philosophy at an organization, you tend to run smoother. So that is DevOps as a whole. It's not a philosophy. I don't like hearing, well, that's the DevOps team over there doing their own thing and everything they're doing is gate kept. I don't think that's the way it should work. When a DevOps engineer is working, they engineer this philosophy to be working inside the organization. So, good segue. Why do we need a DevOps engineer? DevOps engineers work to establish that DevOps philosophy, mindset, and process at the organization. So, think of it this way, that cohesive, stable deployment, fast releases, blah, blah, blah process, that DevOps engineer is working to make that better and better and better. And over time, if a DevOps engineer is doing a great job, the ideal situation is you never really hear from them again. A software engineer is going to create their code commit and they're going to send it up into this process somewhere. And they're going to have knowledge of that process, of course, but they'll have a high degree of confidence that that code commit is going to get to production in the hands of end users with no issues if they adopt that DevOps philosophy. Now, we'll get back to why in the future we don't need a DevOps engineer, um, but we'll get to it in a future slide. So what are the three pillars? This is something that I kind of made up, right? There's no like official DevOps Bible or anything like that that has this as the three pillars or anything like that. But when I think of DevOps practice, these are the three main things that come to mind. Okay. So I mentioned the truck, that's pipelines. This is how that code commit will get to production. There's infrastructure as code. So yes, the code commit is going to production, but what is production? Production is a set of resources, and that's your infrastructure. And so infrastructure needs to be deployed and maintained, right? So how do you maintain it? You maintain it using code, as that's the most repeatable way to maintain it. It is the best way to audit your infrastructure. And it's all about collaboration. We're talking about dev and ops. They have to work together, right? So in order to work together, you have to emphasize collaboration. So let's start with the first pillar. Let's start with pipelines, the truck, the UPS vehicle. Here's a scenario. Let me paint this picture for you. Suppose you have two developers that are deploying an application from their local machine, okay? So week one, let's say Bill deploys the application. Everything is working as expected. It's in production, it's in the hands of real users, everything's good. Week two, Andy deploys the application and it's not working as expected, okay? Clearly, Bill and Andy don't have the same deployment process. Andy probably did something different, assuming the application code is working as it should. Something Andy did in his deployment was different from Bill, and that's why we have issues. So there's a lack of consistency between Bill and Andy's deployment. And what that does is it causes frustration, right? Maybe Andy didn't package it right, or he's missing an environment variable in his deployment. Something is off. So it reveals that we need some like standardized process that gets that code commit into production. We need something standardized, and having separate developers deploy application from their local machine is probably not a good idea. So here's the question, right? Can we outsource deployment? Is that possible? Can we just outsource it to something else so that that same process is happening every single time? And the answer is yes. That's where we use a pipeline. Okay. Now, we, in DevOps, we talk about pipelines all the time. If I asked a developer what a pipeline is, most of them would probably not be able to explain it, right? They'd say it's some pipeline somewhere and they take that word for granted. They don't know what it is. The way I like to explain it in a very, very crude way is a pipeline is a centralized computer or virtual machine based agent. Okay, it is acting on behalf of Bill and Andy. And it's going to behave the same way every single time because you are giving it instructions to act a certain way every single time. So when the code gets merged, the pipeline or some computer, VM, whatever, is executing a certain set of commands, just like Bill would do on his local machine. You're outsourcing it to some centralized VM. And what can a pipeline do? I can make that pipeline do just about anything, right? As long as I give it certain instructions and certain permissions, I can make that pipeline do whatever I want. So in the context of an SDLC, it can provision resources from infrastructure as code. I can take that pipeline and I can deploy real infrastructure, virtual machines. I can deploy storage accounts, whatever I need to do. But that pipeline can also automate your testing. So let's say this. Let's say you have a software application, you build it, but you need to test it, right? You can also trigger that pipeline to run integration tests on it. You can trigger unit tests on it, and you can build and push production artifacts. So think about this. You have a containerized application, right? So you've heard of this thing called Docker before, maybe, but you can build a Docker image, a container image of your application, and send it to some registry somewhere using a pipeline. You can also then take that artifact, that Docker image, and you can send it into your cloud environment so that it is ready for end users to use. So that's what a pipeline is. Instead of Bill and Andy deploying it, you're sending it to some centralized computer, some VM to do it. And the key thing is this is not intended to be manual. Yes, some pipelines can be triggered manually. That's fine. But in the context of the SDLC, if the code gets merged into your main branch, let's say, or whatever branch policy you're using, as soon as it's merged, it automatically triggers this process. So you don't have to worry about it. You set it and forget it. Okay? If you guys know that infomercial, if you know, you know. But that is a pipeline. So here's an example, just as an example. This is the entire process that we showed, that infinity symbol. Um, Here's the example. A developer merges code at step 0, and then it triggers the entire process, which is build and push the Docker image. Let's say it's a containerized application. You build the Docker image and you push it to a registry. Then you deploy that Docker image to the development environment container app. Let's say you have a development environment. That gets approved by QA, and then you deploy that Docker image to the QA environment container app. That gets approved by QA, and you deploy a Docker image to a staging container app. Approved. Once you approve that by a release approver, you can send it into production. There's this promotion workflow that in this case, albeit, is very manual in the sense that you're manually approving, approving, approving. But it's this process that is the same every single time. And all devs do is merge code through a series of steps, and the artifact makes its way to production, again in the hands of real users. This is an example of a pipeline. So the advantage here is that Bill and Andy don't have to touch the actual deployment at all. So we talked about pipelines. Let's talk about infrastructure as code. This is literally infrastructure as code. Let's start with an analogy. Suppose cloud ops, you have, of course, dev and ops. Let's say ops and dev are tasked with implementing an integration between container apps and Cosmos DB. It's a NoSQL database. And the container apps need to connect to the database. So you have a containerized application needing to connect to the database. Ops has to develop the infrastructure for it, and developers have to develop the application code for it. Ops are kind of working over here, and what they're doing is they're creating Cosmos DB and the container apps independently, and have decided they're not going to use local connection strings. Okay, it's not secure to use connection strings because they can be leaked and connected from anywhere. So Ops is saying we're not going to use connection strings in the standard way. We're going to use managed identities. But the developers, not knowing what CloudOps is doing, is developing the application using connection strings. So when developers send this code up into cloud, do you think that this application is going to work? No. And that's because developers have no visibility on the infrastructure that's being sent up, and CloudOps has no idea that developers are using connection strings. So there's a disconnect between the two teams, right? But that's where DevOps is supposed to establish that connection. So how does it do it? Well, imagine you had your infrastructure, your literal infrastructure, held in code. Developers understand code, right? That's what they work with. So the advantage of this is now in a semi-flat setting, they can understand what their infrastructure that they're dealing with looks like and what are its limitations, right? This IAC will give them transparency into what's in their infrastructure. And I think that is probably, in my opinion, the most important thing about IAC. Developers can see what's in their infrastructure and they can say, wait a minute, they're not using connection strings. They're just not. I can see it here. I can kind of make it out. Of course, with READMEs and good documentation, that helps even further. But they could see, okay, it's not using connection strings, so maybe I shouldn't use connection strings inside my application code. And when you do that, now you get more cohesion between the two teams because devs are not even going to develop connection strings inside of their cloud deployed environment. And so you're not going to get weird breaks and fighting between the two teams. Another good reason why you should have IAC is version control and auditing. So obviously, if your code is version controlled using Git, you have snapshots of your infrastructure at a certain point in time. So you're keeping track of all the changes. Imagine all of your changes done in your infrastructure are all done manually. You have no way of fully understanding forever what the changes were and how your infrastructure evolved, right? So you have no idea, did it become more secure? Did it become less secure? What changes were made? Who made the changes? With IAC and Git, you can actually audit your changes and say, this is what I did. And because it's code and you have a process, a pipeline, right? You can repeatably deploy your infrastructure in a reliable way so that you know if you hit the button or if you merge your code in, it's still going to operate as expected and there's not going to be like random changes. You'll be able to say, hey, wait a minute, someone made infrastructure changes manually because the snapshot I have here in Git looks different, right? That looks way different. So let's like change that back or consult someone on the team that made that change. So what are some popular IAC languages? Some popular IAC languages include Bicep, you have Terraform, you have a fork of Terraform called OpenTofu, but there are others, right? These aren't the only ones. The thing with DevOps is there's so many tools, but the ideas are all the same. I should have mentioned this, but yeah, going back to manual deployments. Imagine you have to set up infrastructure and you have four environments, right? Let's say dev, QA, staging, production. Okay. Imagine you set up all that infrastructure in Azure, AWS, whatever, manually. All the settings that you have to do, if you have any idea how to deploy infrastructure, it could be a mess. Imagine you did everything manually, right? It would be a nightmare to do this outside of IAC. You would have to do so many changes. You have to make sure all the changes are identical. It would take you forever. But with IAC, you can accelerate that. So what can we deploy with IAC? What infrastructure can we deploy? Just about anything, really. Web apps, containerized apps, databases, virtual networks, firewall policies, private endpoints, anything. So that's what you can deploy with IAC, and that's the value of IAC. Let's go to the cultural side of DevOps. So um, with this process, with IAC, what are we building? We're building three things: trust, learning environment, learning platform, transparency, and it's ever increasing, right? And it's that culture where CloudOps is sharing their IAC and Dev is sharing product implementation. And once you have that, you get the two teams becoming one cohesive unit, as I mentioned earlier in the video. So we talked about development team, um, we talked about CloudOps sharing information on the infrastructure IAC with the development team, but why should CloudOps know more about the product, right? Both sides need to know more about each other. Here's an example. So let's say there's a flag in some database where if it turns to true, virtual credit cards are depleted. And let's say that flag gets stuck and business is impacted after a few days. Let's say that information right there, the first sentence, is not shared with the infrastructure team. If it's not shared with the infrastructure team, the few days are going to go by where now the virtual credit cards are depleted, and that's going to impact business. If ops is made aware of this issue, maybe ops can set up an alert and notify the engineering team and say, hey guys, we're seeing VCCs are being depleted and they're not being replenished. So here's an alert, fix it, and then you have no issues. It's not going to hit business. So it also helps you resolve incidents, diagnose issues, identify root causes if CloudOps has an idea of what limitations the product currently has. And of course, that improves service reliability. So let's say we adopt DevOps as a culture. Okay, we have processes in place, everything's good. So how can we actually measure improvement over time? Well, it's important to keep track of certain metrics, right? So the MTTR is the mean time to recovery. So what does that mean? It measures how quickly teams are able to resolve or restore service after incidents, right? So ideally, you want a metric like that to go down, right? So you want less and less time spent in order to restore service. So here's the graph right here. It's this one, MTTR, just made some fake data over a span of 4 months. It goes down. That's a good sign. What about deployment frequency? Well, how often does code get released to production? You want that number to typically increase, right? So you want more and more deployments to production um, within a certain unit of time. And that tells you, hey, I'm getting more features out to the end user, right? So that's good. That's this line right here. It's going up. Perfect. Lead time, that measures the duration where a code commit is created and it gets to production. You want that time where the code commit gets created to production to go down, right? Because you want to get that code commit all the way to production in the fastest time possible. So that would be this one right here, for example. Fake data again, but whatever. And the change failure rate. This is the percentage of deployments causing production failure. Do you want that number to go up or do you want that number to go down? I would think you would want that number to go down. You want less deployments causing production failures over time. You want to stabilize your deployments. So in that case, you want it to go down and ideally 0. Chances of that happening are pretty low, but you want it to go as low as possible. These are the KPIs where, if you're starting at a company as a DevOps engineer, I'd probably start measuring this, right? Like, okay, what do I have right now? Okay, month 2, what do I have right now? Month 3, what do I have right now? And show actual process and how it's improved our organization. So, going back to our question. At the beginning, I asked, what are some pain points in a software development lifecycle where you take a code commit all the way to production? What are some things that you could have problems with? Well, manual code deployments, right? Bill and Andy, going back to them. If you are manually deploying code, two deployments might not be identical, and so you have issues, and Bill and Andy are going to start fighting. So we can fix that by sending it to a pipeline. Manual infrastructure provisioning. If I am deploying 4 environments manually, chances of them being identical are very low. Good luck. But if you have IAC, you can templatize, use templates, and you can send in certain parameters per environment, and you could deploy it. Once you have one environment, you can deploy all the other ones very quickly. Um, it's something really didn't talk about. It's impossible for me to get through everything, but branching strategy. Sometimes you could have Git flow branching strategy where you have multiple long-lived branches, and that could end up into merge conflict hell where you're trying to resolve merge conflicts. You have no confidence that your code in this environment matches this in this environment post deployment. So DevOps can help like streamline that by going more toward a trunk-based development lifecycle where you're only dealing with a mainline branch, but I won't go into further detail there. Some teams do manual testing, so I had that example of the pipeline where I was saying, well, manually approved by QA, move to this environment, so on, but you could automate your testing, right? So you could have integration tests post-deployment that trigger, and if they're all good, then you can promote that artifact through all of your environments. Um, and it can also help solve this issue of lack of overall transparency and communication. So I mentioned IAC. That's a critical thing for transparency. This is what the infrastructure is. Uh, consistent talks on what the product limitations are with ops so that they know and they can work together to develop proper alerting um, and proper strategies for rollback. So, short term, what does short term DevOps practice look like? Let's say you're starting at a company, you're the only DevOps engineer there. So, what would it look like? Let's say developers need to create a service, so they create a repository, right? A Git repository on Azure DevOps or whatever, GitHub. DevOps engineers, day to day, will create pipelines to build that application and send it into each environment with proper promotion workflow. What they'll do is they'll contribute to infrastructure as code surrounding this service. So maybe the service needs a container app or something like that. So they'll develop IAC for that. And all relevant teams, cloud ops, developers, QA, will all be notified of what this process is so that they have a good idea. It'll be documented. And once that's fully shared, all future code pushes will result in continuous delivery, continuous integration, CI/CD. CD typically means deployment, continuous deployment, but you could have continuous integration, continuous delivery. Continuous delivery, it's when you generate your build artifact over and over and get it ready for release, and continuous deployment actually means taking it and deploying it continuously to production. So that's short term. And in a short-term setting, DevOps engineers are still needed in a day-to-day basis for contributing to necessary pipelines and IAC per service. So they need to be there, right, to develop this entire process. But I mentioned earlier that DevOps, if you're doing DevOps right, over time, DevOps engineers are no longer needed. So what did I mean by that? Long term, this is how it should look in my view, right? DevOps is not well defined everywhere. It's not the same definition everywhere. This is how I see it long term. Developers will create a repository. Let's say they have a new service, and you'll have automations using platform engineering. You can build automations that creates your pipelines and automatically sets all the standards for that pipeline for this service so that the DevOps engineer is not creating that pipeline manually. There's a standard that you're following. And as soon as they create the repository, the automation builds that pipeline for you. And all environments related to this service will be generated by IAC and pipelines automatically. And once that's set, documentation will be prepared, all relevant teams get notified, and all future code pushes again result in CI/CD. So in this case, the DevOps engineer has set up this platform engineering system that takes that repository and builds everything according to a certain standard that everyone agrees on. And they're just sitting back, sipping cocktails. DevOps engineers help build the automation and document every step for complete transparency in the long term. Over time, DevOps engineers are not as needed on a day-to-day basis because they set up the system for developers to work. And developers, all they need to do is work on code, right? So they do what they do best. And developers do what they need to do with minimal to no supervision. If there's guardrails in place. The way I like to think of it is, if you're bowling, there's those rails that you put so that the ball doesn't sink, and the developer is able to actually hit a strike every single time, or at least not hit the gutter. Um, and that's what this is. The DevOps engineer is building this beautiful automation process with a lot of upfront work, but over time, they slowly fade into the background if they're doing a good job. Future discussions, future videos on this channel, what I want to talk about is pipeline in detail. I want to talk about IAC in detail, infrastructure as code. I want to talk about what is a container app, right? What is a container? A lot of teams are adopting Kubernetes, container apps, containerized Azure container instances, whatever. So it's good to be able to talk about what a container is, what Docker is in that case. I could show a demo, like building infrastructure manual in the cloud, or any topic you want to leave in the comment section. So if you guys see anything here that's of value, or anything that you can think of that's of value that you want me to go over, please leave it in the comments and subscribe, hit that notification bell, and I'll be happy to share that information with you. Thank you so much, guys. I know there was a lot of information today, but I hope that was helpful. And reach out to me on LinkedIn, Martin Nicola, and looking forward to hearing from all of you guys. Thank you so much. Cheers. Have a good day.